Well, hi and welcome. I'm going to do a short tutorial on how to utilize LTSpice to get one of your first circuits up and running. And the circuit I'm going to do is it's going to be a simple DC chopper circuit with a MOSFET. And first thing to do is to get MATLAB up and operational. And I already started here, so let me pull it into the window. Hold on, and I've already populated with a MOSFET. Let me delete this. We can get rid of this one. The LTSpice is free to download. It's not always as intuitive. It actually is pretty intuitive, but it's a little bit different than other Windows programs that you may be used to. So to delete something, I'm going to grab the scissors and we're going to just cut that out. And usually as you start this, I'm going to say no. We start with a blank canvas here, and you'll go up and say File, New Schematic, and we'll start a new schematic. A chopper circuit consists of what's called a low side switch, and we'll learn about what low side switching is. And I'm going to assume a resistive network. And the chopper circuit I'm designing is we're going to design this to handle only about 1 amp from a 20 volt DC source. So 1 amp from a 20 volt DC source means that my resistance should be 20 ohms, just V equals IR. So to put that component in there, up here you'll see there's a resistor. I want to put a voltage source across this, so I click on Component, and you'll see this screen will pop up. And to put a voltage source in, there's all the different sources you can include. Right here towards the end, it's in alphabetical order. Voltage, you click on that, hit OK, and there we'll put our voltage source in. So hit Escape, and you'll get the cursor back. Let's make this voltage source, it's a DC source, we'll make it equal to 20. We could put series resistance in there. I typically will model that outside of the source if I'm going to model that. And let me change the name as well. And it's called V1. I'm going to call this V sub source. But you can call it whatever you want. The MOSFET I'm going to use, and it was one I just picked somewhat at random. I found it's a model that was in it was already pre-built into LTSpice. It's going to be an IRF 8721. It's rated for 30 volts for drain to source. It has 8.5 milliohms as its drain to source resistance when the gate to source applied to it is at 10 volts. And here's all the specs. For an ambient temperature of 70 degrees, which is pretty warm, it can handle up to 11. I would derate these even more. It can take pulsed current up to 110 amps, 11 amps. We're putting 1 amp, so that we're not going to stress it too much. Where I probably am stressing it more than I'm comfortable is applying a drain to source voltage of 20 volts across that. But with a resistive load, we're not going to get any inductive voltage spikes across that. So this is the MOSFET I'm going to use for the DC chopper. To get that MOSFET, I'm going to go up to Component up here. And if we come over, and you'll see NMOS. There's NMOS 4, which is going to give you the body as its separate connector, but we'll just select NMOS. DC chopper, it's a low side switching topology. And now once I place that there, I've got to select the MOSFET. So you highlight, right mouse click. Let me cancel this and close this out. You go into the device and right mouse click, and you'll pop up a screen like this, and we're going to say pick new MOSFET. So if I do that, there's a number of MOSFETs to select from. I can select based on this VDS. Here's the actual model. The models built into LTSpice for the MOSFETs are a little bit different model than Spice. It's I may do another tutorial on how to build these. It's not easy necessarily. They're called DMOS. It's a different type of modeling. I will do another tutorial on how you can bring in other manufacturers' models if you have a different MOSFET that you want to use, and how to build those as opposed to using what's already pre-built into LTSpice. It's somewhat limited on the power switches or the power MOSFETs you can use. So being able to bring in other ones is oftentimes what you may do as opposed to using the built-in ones. But for this example, we're going to use the built-in one, and I got to find, where is that IRF? Maybe I should sort on part number. IRF 88. Oh, it was up. Where'd it go? 88721, right there. Okay, and so one of the things you want to learn quickly is to use the spacebar. If I tap the spacebar, it will size the screen to fit exactly, and then I can use the scroll wheel on the mouse to expand or shrink down. So I'm going to wire this circuit up. If you go up here by the pencil, it's your wiring, and you can wire through the device, and it will actually connect it up. And then let me go here, and we're going to wire down through these, and it will actually connect all of them up. And one more, and bring that wire. And so you see it wired it up. I have to add a reference or a ground here. I'm going to put that in there. Wire that ground. Make sure, a lot of mistakes I sometimes make is I don't wire a ground in, and it'll give me some issues. So we have our 20 volt source across, I'm going to hit the spacebar and resize the screen, across our 20 ohm load. And now I have to put a gate, and I want to make this a chopper, so I'm going to put a pulsing voltage source there. I'll show you how to do that. We're going to go get another voltage source. All right, that is going to provide our gate to source voltage, and I've got that connected up. Let me give this click advanced. So if we go in here, I want to click the advanced, and that's going to allow me to create a pulse. And our pulse is going to start at 0, and it's going to pulse up to 10 volts. If we go back into our screen, we see the ratings for this one. We're all at the gate to source at 10 volts. So I want to pulse this thing up to 10 volts. I'm not going to put a delay in there. I will put a slight rise time of 1 nanosecond, a fall of 1 nanosecond. Let's switch this thing at, I think we can switch this at a 1 kilohertz rate, which is pretty slow. And so doing that, our time on would be half a millisecond, and our period would be 1 millisecond. And we'll do, let's say, 10 cycles and hit OK. And that has now created a pulse that's going to chop and turn on and off this MOSFET. And then the last thing I want to do before I run this is I want to do a transient analysis. So .tran, I'm going to go from 0. Now we did 10 cycles at 1 millisecond, so I'm going to do a transient analysis for 10 milliseconds. So .tran, it's a SPICE directive from 0 to 10 milliseconds. And I'm going to put that right here. Again, I'll hit resize our screen. Now I have my circuit all set up. I can save it. I'm not going to save this one, but I encourage you to save early and save often. And now if we find the running man or running person, it's, I don't know, it looks like a running stick figure. We're going to hit run, and that's going to do a transient analysis. And I can now plot different things. So let's say, for example, I want to plot the current through the resistance. I take my cursor, and it will create an arrow, and as you see, the arrow's right there. And if I click on that, you'll see we have the current, and sure enough, there we have a current that is at 1 ohm, 1 amp, and it's going up and down like it should be. We can resize our graph if we want to. I may want to look at the voltage across the load as well. If I do, I'm going to put the cursor above the resistor. I have to hold the left mouse button down, and then I pull all the way around, and you'll see now I've got my 2 probes. But you got to be holding that mouse probe or that mouse button, and there we go, and we have our voltage, and it's overlaid on the current. Let me delete the current trace, and there's our voltage. You see there's a little bit of overshoot here on this, and sure enough, it's a 1 kilohertz periodic waveform with a 50% duty cycle. The other thing we can also look at, I'm going to delete this trace, I might want to look at my instantaneous power in the FET, and if I do that, I want to do, I hold the Alt button down on the keyboard, and then I hover over that, and you'll get a thermometer, and when I do that and then click the mouse, you'll see we've got an instantaneous plot of the power, and there's this big spike that happens at up to almost 48 watts of really short-term power. If I can zoom, I'm going to zoom in on that, and you'll see that there's this big spike. And the other thing you'll see is when it's turned on, there's a slight rise of conduction power loss through there. And we're going to talk more about that as class goes on. But that spike comes from the fact that we cannot turn these on instantaneously or turn them off instantaneously. And we'll talk more about the switching characteristics of MOSFET. But this tutorial was really to get you up and running on building hopefully one of your first circuits in LTSpice. Thanks for watching.